So in the previous lecture, we had seen that what are the facts that we need to remember when it comes to the distribution of oceans and continents. And we have seen that it was Alfred Wegener in 1912 who had given this theory of continental drift. And in this theory, we see that there was a one big continental mass which was called as Pangaea, and the ocean what was called as Panthalassa. Never mind the pronunciation, you can remember the spelling. It's Pangaea, right? And it was Panthalassa. Then Pangaea broke off into Laurasia, that went in the northern hemisphere, and Gondwana land, which went in the southern hemisphere. That is what we have discussed. But what was the basis of the theory proposed by Alfred Wegener? Because earlier we have seen that it was Antonio Pellegrini and Abraham Ortelius who have tried to give propose this kind of theory regarding the movement of the continents. So the evidences that are available with respect to the theory of continental drift, the very first is the jigsaw fit. Now, what is the jigsaw fit? So if you closely, move the shorelines of Africa and South America facing each other, they have a very remarkable and unmistakable match. They directly fit into each other like pieces of puzzle. सो ये ज़रूरी है हमारे लिए देखना कि एक कंप्यूटर प्रोग्राम के माध्यम से अगर हम ये चीज़ करें, राइट, सो ये आपने को देखने को मिलता है. सो इट मे बी नोटेड दैट अ मैप प्रोड्यूस्ड यूजिंग अ कंप्यूटर प्रोग्राम टू फाइंड द बेस्ट फिट ऑफ द अटलांटिक मार्जिन वाज प्रेजेंटेड बाय बुलार्ड इन 1964. सो एल्फ्रेड वेजनर की कॉन्टिनेंटल ड्रिफ्ट थ्योरी 1912 की उसको काफ़ी सपोर्ट मिला 1964 में. So that particular mapping done by computer program proved to be quite perfect, right? The match was tried at 1000 fathom line instead of the present shoreline. Now, what is 1000 fathom line that we need to understand here? So what are fathom lines that we wanted to discuss? Now, fathom line means that you're not just looking into the shoreline that we see today. This is also including the continental slope and the continental shelf line. So they combined that together and they found that there is an unmistakable match. Every piece of a puzzle fits into each other as if a big piece of land existed. So the computer program Bullard 1964 somehow proved that the basis on which Alfred Wegener gave proposed the continental drift theory was substantially true. So this is called as a jigsaw fit. Now the second evidence that we have is the rocks of same age across oceans. This is very important. So radiometric dating, I mean that's a technology by which we try to assess the age of the rock, how old it is. So the radiometric dating methods which were developed very recently, they helped us in identifying and correlating the rock formation from different continents. So the belt of the ancient rocks of 2000 million years were found near Brazil, right? And this particular rocks matched with what was found in the western part of Africa. Now, if you will notice the location of Brazil in South America, you will find that it is in the eastern side. And the western side of Africa, the ocean rocks were nearly of the same age, 2000 million years ago. Earliest marine deposits along the coastline of South America and Africa are of the Jurassic age, same, which means that to an extent South America is closely related to Africa. This suggests to an extent that ocean at that point of time did not exist and came at a very later stage. It might be because these lands separated and then water came in, or it might be that the water came in above the land and these lands got submerged. So these are the possibilities that scientists are basically moving towards. But then this indicates that some sort of movement has happened. Either the land has separated or the water has moved. Now the third thing is called a stellite. Now what is stellite? So stellite is a sedimentary rock formed out of deposits of glaciers. So it is the sedimentary rock formed out of glaciers. The Gondwana system of sediments from India is known to have its counterparts in 6 different land masses of the southern hemisphere. Now that what we come to know about India is that whatever landmass that India has, basically you're talking about the peninsular India, it is a part of the Gondwana system. Now where was Gondwana system? Remember from lecture 1 there were two areas, Laurasia and Gondwana. So Laurasia was in the northern part and Gondwana was in the southern part. So Gondwana system, India happened to be 2000 million years ago. India happened to be, this landmass happened to be a part of the Gondwana system, and this system is similar to six different land masses which exist today in the southern hemisphere, south of equator. At the base, the system has a very thick tillite indicating extensive and prolonged glaciation. Now, glaciation is obviously a physical process. That is when the water, the ice, the big blocks of ice reacts with, or you can say, comes into physical metamorphic process with the rocks. And these are present in Africa, Falkland Islands, Madagascar, Antarctica, and Australia. All of this has a same similarity with Indian rock system. So, over resemblance of the Gondwana type of sediments clearly demonstrates that these land masses were part of common history, common physical rock history. The glacial tillite provides unambiguous evidence of paleoclimates and also of drifting continents. Paleoclimates. The word paleo indicates primitive climates. So what could have been the climatic conditions at that point of time when the Africa, Falkland Islands, Madagascar, India, Australia were part of a common unit, and Antarctica as well. So you can find that Antarctica also has a rock system which is very closely related to the Gondwana system. Though it is covered in ice, but still, at one point of time, it must have been a part of the bigger landmass. So, tillite, glacial tillite, is the conclusive evidence largely. So, we have seen that there are three evidences so far. First was the jigsaw fit, the computer program of Ballard of 1964, which joined together using the fathom line, the shore lines, including the continental slopes, and it all fitted into one piece of puzzle. The second evidence that we have seen is coming from the South Atlantic Ocean, where the kind of ocean rocks found on the western part of Africa is very similar to what is found near Brazil. And the third is the Gondwana system similarity of India with six other land masses of the southern hemisphere, that is called as tillite glacier formation. These three things you should remember. I have explained you in a very short form, in a very short manner, and you can write this down. And the fourth, very close, very good evidence is the placer deposits, and fifth evidence is the distribution of fossils. Distribution of fossils, placer deposits, these are other two evidences that we are going to discuss in this particular video itself. Now, what are placer deposits? So, placer deposits of gold in the Ghana coast, that is in Africa, and absolute absence of source rock in the region is an amazing fact. The gold bearing veins are in Brazil, and it is obviously that the gold deposits of the Ghana are derived from the Brazil plateau, where the two continents lay side by side. Now, what is exactly placer deposits? We also need to understand here, right? Because there is some sort of similarity with Africa and South America. So, do one thing. Right now, pause the video, open an atlas or open the world map. Look at South America. Look at Africa. Look at the eastern coast of South America. Look at the western coast of South Africa. And in the western coast, try to remove the upper broader area of Africa. Take that broader area of Africa towards South America and fit it above South America. You will find that there is some sort of exact curve line that is there, right? Coming to placer deposits. So, to understand the idea of placer deposits, imagine that first we need to understand the sedimentary process. Now, sedimentary process is when one layer of rock is, or you can say dust, is settling over another layer of dust over a longer period of time. So the time period will be very long, right? You can consider like millions of years for that matter. Now, placer deposits simply means that जब एक कोई चीज़ लूजली हेल्ड हो या स्लिप हो जाए और धीरे धीरे खिसक खिसक के दूसरी जगह जाके डिपॉजिट हो जाए. टू सिंपली अंडरस्टैंड इट, इमेजिन दैट अगर आप कोस्ट लाइन किसी बीच पे खड़े हैं और आपने एक रेत का पहाड़ बना दिया लंबा सा, तो वेव अगर आएगी तो वो रेत को उस जगह से खिसकाते हुए आगे तक ले आएगी, और जो रेत का पहाड़ आपने एक जगह पे ऊंचा बनाया था वो छोटा होके फैल जाएगा. तो जो फैलने वाला प्रोसेस होता है इसको बीच डिपॉजिट्स कहते हैं. एक तरह का प्लेसर डिपॉजिट का मैकेनिज्म है। तो यहाँ पे आपको जो प्लेसर डिपॉजिट्स है वो अफ्रीका और ब्राज़ील के बीच में बता रहा है। कह रहा है कि रिच प्लेसर डिपॉजिट्स ऑफ गोल्ड जो है वो घाना में है, घाना कोस्ट में है। घाना ईस्टर्न पार्ट ऑफ अफ्रीका पे है, सॉरी वेस्टर्न पार्ट ऑफ अफ्रीका पे है। घाना में गोल्ड के प्लेसर डिपॉजिट्स पाए जाते हैं, राइट। और जो एब्सोल्यूट एब्सेंस ऑफ सोर्स रॉक इन द रीजन का मतलब ये है कि घाना में किसी भी तरह का ऐसा कोई रॉक नहीं मिला जिससे कि गोल्ड को पाया जा सके, जिस जो कि गोल्ड का सोर्स हो या प्रेशियस मेटल का सोर्स हो। लेकिन इसी तरह की गोल्ड बियरिंग वेन यानी नदियाँ जो हैं वो ब्राज़ील में देखने को मिलती है। तो इसका मतलब कभी ना कभी ये जो प्लाटू है ब्राज़ील में और जो घाना का जो रीजन है वो जुड़े हुए रहे होंगे। तो प्लाटू से कुछ चीज़ सेडिमेंट खिसकी और घाना में आ गई। तब घाना में जमा हो गई, उसके बाद ब्राज़ील और घाना का लैंड मास एक दूसरे से अलग होना स्टार्ट होता है। तो ये प्लेसर डिपॉजिट है। अब प्लेसर डिपॉजिट्स के बारे में आपको क्या याद रखना है, दैट इट इज़ वन ऑफ द एविडेंस फॉर कॉन्टिनेंटल ड्रिफ्ट थियरी। Now, this is the depth that you should always remember, and that is why whatever I am trying to tell you orally, I expect that you're writing it down. Because इन वीडियोस का फ़ायदा यही है, द एडवांटेज ऑफ दीज स्मॉल वीडियोस इज दैट आपको कुछ भी लिखने का ज़रूरत नहीं पड़ेगा। आई मीन यू डोंट हैव टू रीड इट, you just have to listen to my particular videos and I am explaining everything to you line by line. So you just have to write it down. The sixth evidence that we have is the distribution of fossils. Now, when identical species of plants and animals are adopted to living on land or in fresh water, right, they are found on either side of the maritime barriers. Problem arises regarding accounting for such distribution. How these fossil fuels, these identical species of plants and animals who are accustomed to survive or adopt in a particular environment, in a very common environment. So, these observations that lemurs occur in India, Madagascar and Africa, lemurs, right? Africa, Madagascar and India, led us to believe that this particular species was part of the same land, and that is why these contiguous land mass is called as Lemuria, linking these three land masses. Now, another important MCQ. It can be asked that the term Lemuria seen in geography refers to which three regions, right? So you should remember that it is India, Madagascar, and Africa. By the way, Madagascar is a very small island country on the east coast of Africa. Lemuria, because of the presence of lemur. Now, Mesosaurus was a small reptile which adapted to brackish water, which means the salt water. Now, the skeletons of this Mesosaurus is found in two localities, Southern Cape province of South Africa and Iravar formations of Brazil, which means you will find that the southern part of Brazil and South Africa found has skeleton presence of Mesosaurus. Now, this indicates that again Mesosaurus occupied a piece of land which was very common. They were joined together. Now, these two localities presently are 4,800 kilometers apart, with ocean separating them. So, the present distribution of fossils, I mean, presence of similar species in different regions indicate us, and proximity, geographical proximity, closeness of these land masses towards each other indicate that millions and millions of years ago it is a possibility, it is a very strong possibility that this was one piece of land. Now, whether land moved away or due to weathering, what happened, land went on to decrease in its height and water took over. Now, that is a speculation. See, again, you can construct history going back in time, right? So, this is just a theory. Now, what are the evidences? You cannot prove this theory, but yes, you can collect evidences in favor of this theory. So, Alfred Wegener proposed a theory in 1912. The very modern and scientific evidence are two, that we had first, did a radiometric study of the age of the rocks, and that is very similar. The very strong reason was the use of the computer program by Bullard in 1964 to join this. The glacial tillite that is there in the Gondwana system and linkage of Gondwana system to 6 regions, Africa, Falkland Islands, Madagascar, Antarctica, indicates us that another it is a very strong reason. And placer deposits along with the presence of fossils. Now, these are the evidences using which the theory of continental drift is proposed. So, summing up, what are the six evidences that we have in the support of continental drift? First is the jigsaw fit, right? The matching of the shorelines of the continents. Then the age of the rocks, similarity in the age of the rocks across oceans. The third is remember that it is glacial tillite. The fourth is the presence of placer deposits, and the fifth is the distribution of fossils. So these are the five evidences that we have with respect to continental drift theory. Now, what we are going to do in the next part of the video is we are going to study the post drift theory studies, that is related to convectional current theory, the mapping of the ocean plains. Then we are going to study in the next part what is ocean floor configuration and how are earthquakes and volcanoes distributed. Largely, this is the scope of your current lecture. Though we are only going to discuss the theory part, and you can also at the same time I'll be telling you when to look into the map. So definitely look in the description box for the next video, and I'm going to make your study of geography very simple, very easy. You just have to put your earphones on and focus on what I'm talking about, right? So I'll see you guys in the next. Do watch the next video. Thank you so much.